Okay, so this is the rest of the lab of how we did the collection of hydrogen gas by water displacement through a single replacement reaction. I have the picture of the magnesium weight on the balance. I have now tied a string around it and have the piece of magnesium kind of folded into the C. And I have my burette with concentrated hydrochloric acid. The first thing that I have to do now is I have to add water to the burette, to the top. The acid is all down here at the bottom, so I'm going to take the stopper out. Gonna just gently pour the water down into So I'm filling it up almost to the very top. Now I'm going to take my magnesium that is on the string. I'm going to take it and push it down into the water. Now I'm gonna have to use the thermometer to kind of help me get it to go down into the water. I want to get it to go down a little bit. Okay, maybe see if I can inch it down a little bit more. Doesn't really, the string is sticking to the side. Okay, that's actually going to be good enough. Now I want to fill it back to the very tippy top so there's no air bubbles. Okay, I'm going to put the stopper back onto it. Now the magnesium is right here. Okay, I'm hoping that you can see this. The magnesium is right here. Okay, the acid is still all pretty much down at the bottom. So I'm going to turn this over into the big beaker. And when I do that, the acid's going to run down. Okay, so the acid is now running down from the top down to the bottom. And then the reaction will begin. The magnesium is still just right about here, about water height in the tube. Now, as we're doing that, we can take the temperature. The temperature of the water is right at 23.0 degrees. The temperature of the water is 23.0 degrees. Record that onto your data. I don't know, hopefully you can see the bubbles. The acid is just now getting down to the bottom. Bubbles are beginning to form. That's your hydrogen gas being released. The reaction will proceed faster and faster as more and more acid makes it down towards the bottom of the gas collecting tube. Now while that's kind of reacting, I'm going to fill this other beaker with water. It's beginning to go faster now. Again, this is collecting a gas by water displacement. It's going very quickly now. Okay, so now the reaction has stopped, meaning that all of the magnesium has reacted. The water level inside the tube is about here. It's just a little bit above the water level outside the tube. So I'm going to add, let me see, did Did the temperature go up at all? Not significantly. So I'm going to add water until the water level inside and outside the tube are exactly the same. Because once we get the water levels the same inside and outside the tube, now I know that the atmospheric pressure pushing down is the same as the pressure of the gas is in here. So the pressure in the tube is the same as the pressure outside of the tube. So when I go and read this now, when I go and read the water level, it says that it's, let me see if I can see the numbers here. There's a glare. 45, 46, 47, 47, these lines. It says that it is 47.40. 47.40 milliliters. So again, 47.40 milliliters of gas is what we collected. The temperature was 23.0 degrees. The only other thing we need is atmospheric pressure. So I'm gonna go and I'm gonna ask and say, hey Siri, what is atmospheric pressure? And we're gonna have to look that up, and I will take a picture of atmospheric pressure for what it is right now today, and we'll put that as a additional picture with this video for your data. And that's pretty much it. You record your observations as far as what all we saw as the reaction took place, and you'll be able to do the calculations from there.